In this section, we'll talk about what calculus is all about. And why would we do that? Well, because having a template and a basic understanding of what you're going to learn will be important and helpful for you in understanding the subject and concepts that are going to get introduced. So we start calculus by introducing the concept of functions. We continue by learning about the concept of limits, and then we introduce a derivative until we reach the integral. And basically, calculus aims to solve two main problems: the problem of area and the problem of the tangent line. First, on the problem of area. And why is it a problem? Well, because up until now, we've been finding the problem of basic shapes like a square, a triangle, a rectangle, and circles. And when we got introduced to a new shape that we didn't have a basic formula for calculating its area, we use the method of exhaustion, and the area of a square is a side squared. For example, if we had a polygon like so, we can find its area by dividing this shape into the basic shapes that we know the area of. This is a triangle, and this one shape is also a triangle, and this one here is a rectangle. So the area of the full shape, if it were to be A, is going to be A1, the area of the first triangle, plus A2, the area of the rectangle, plus A3, the area of the second triangle. This method is known as the method of exhaustion. But what if we were to get introduced to a shape like this one? Well, in this case, we cannot divide this shape, the basic shapes that we know the area of. And this is where integrals come into play. Using the integral, we can find the area of such shapes. And the basic idea is to divide this shape into an infinitely many rectangles. And each rectangle of those rectangles has a width of dx. And dx in calculus means a little bit of x. So we're still using the method of exhaustion, but in this case, we're using infinitely many basic shapes to calculate the area of the whole shape. On the problem of the tangent line, well, to define this problem, we have to begin by understanding what a tangent line is. A tangent line, by definition, is a line in which it touches a curve in one point and one point only. So let's say that we have a curve, and this is a point we'll call P. A tangent line on a point P will be such a line. This line only touches the point P. So where is the problem? What we aim to do here is to find the slope of this line. Well, up until now, to find the slope of lines, we were using the rise over run formula. y2 minus y1 over x2 minus x1. This gives me the slope of a line in which y2 is the y coordinate of the second point and y1 is the y coordinate of the first point. x2 is the x coordinate of the second point and x1 is the x coordinate of the first point. So we have to have 2 points to calculate the slope of a line. But in the case of a tangent line, we only have 1 point on that line, and that point is P in this case. So you see where the problem is. We have to come up with a way to calculate the slope of a tangent line, and this is where the derivative gets introduced. Using the derivative, we can find the slope of a line, the slope of a tangent line. And using the integral, we can find the area under a curve. And we'll do both of these calculations using the limits. And the modeling of stuff we'll do using a function. So everything works around a function. We take the limit of a function, we differentiate a function, and we take the integral of a function. So differentiating a function will give me the slope of a tangent line, and integrating a function will give me the area under the curve that represents that function. And taking the limit of a function will enable us to differentiate and integrate a function. So this is what calculus is all about. I hope this gives you a basic understanding of what we aim to do with calculus.